So, good morning, students. Today we'll discuss about 2.3.11 packet tracer activity. Determine the DR and BDR in OSPF. Okay. So, before we go into this topology, we should know some basics about what is OSPF, what type of routing is used in OSPF, then what is DR, what is BDR, like that. Okay. OSPF is known as Open Shortest Path First. It's a link state routing protocol. They calculate the shortest path based on Dijkstra's algorithm. Okay, it's a multi-access network. That means many routers are connected to a switch network, and in OSPF, no, every router will send the link state advertisements that contains the shortest path. So when each router sends this information to and fro, there will be more congestion in the network. It will slow down the performance. So what we will do to solve this issue, we will introduce one router as DR, designated router, and all the other routers, no, they will send the shortest path to this DR. The second one will be BDR. If the that is called as backup designated router. The DR router is down, then BDR will take the charge of designated router. Okay. What about the election? How do we choose one router as DR and another one as BDR? How? The router with highest priority, OSP priority high, will be chosen as DR, and the router with second highest OSP priority will become BDR. The priorities are same, then we have to choose the DR based on router ID. So how do we choose the router ID? First thing, you can manually configure the router ID like router OSPF process ID, then router ID number 11 or something 22. Okay. Then, if not manually configured, you have to find the highest IP address on any loopback interface. Okay. There is no loopback interface IP. And in L0, in L1, no IP means find the IP address of the interface. Which interface has highest IP address, like FA0 bar 0, FA0 bar 1, which one has highest IP address? Choose that one as router ID. Okay. Now we go for the topology. Yes. Three routers, RA, RB, RC, each one has loopback interface L0, L0, L0. Okay, so we'll start with packet tracer 2.3.11. So there are two parts, part 1, part 2. So first we need to go for part 1, examine the DR and BDR changing rules. Okay, so first thing is you have to wait for the amber to turn to green. Okay, the spanning tree protocol is being working on background. Okay, now it's green. Now we can start the activity now, or we can just click the fast forward. Okay, now we need to see the topology. We have three routers, RA, RB, RC. Okay, this is RA. The loopback address is 192.168.31.11. Then the interface IP is 192.168.1.1. Then RB, the loopback is 192.168.31.22. And this one is the G0 bar 0 interface IP 192.168.1.2. And this one RC is 192.168.1.3. The interface IP loopback is 192.168.31.33. Okay, here, so we have to check the which router is DR and which one is BDR and which one is DR other. Okay, so for that I'll go to each router. So first I'll go to RA and I'll use the command show IP OSPF neighbor. Okay, we can see 192.168.131.33 is DR, designated router. Okay, 31.22 is full BDR, that means the backup designated router. So what is that 31.33? That is the IP address of loopback interface of RC. So this will be the designated router. And 31.22 is the loopback IP underscore RB. So this is backup designated router. Okay, this will be DR other. So what does these are means? As I told you, designated router, all the routers will send the link set updates to this designated router to avoid the broadcasting. Okay, that again that which one, no, traffic and all. Avoiding that one, we can select one as DR. If the DR is down, then BDR will become DR. Okay, do this for all the routers and find out which one is DR, which is BDR. Okay, so IP SPF neighbor 31.33 is DR. So see, this is D. 31.11 is DR other. This one. Okay, this is now BDR. Now go to RC also, do the same command. 11 is DR other. This is 11 RA DR. 22 is BDR. This is 22 RP BDR. This one is RC. Okay. Now which route is DR? RC. Which route is BDR? RB. What is the OSPF state of RA? Okay, how we check that state? I already know this is DR other. How do we check that? Again, we have the command show, go to RA, show IP, show IP OSPF interface. You can see DR other state. Do the same in RC. Okay, same command show IP OSPF interface. You can see this RC is DR designated router. What about RB? Show IP OSPF interface. It is BDR. Okay, done. Now turn on the IP OSPF adjacency debugging. So we want to debug, you want to check that adjacency forming and all. No, that monitor the election process between routers, which one become DR, which one BDR. Like the election process you want to see means try this command debug IP OSPF adjacency. Go to each router and do this. Okay, I'll go for first RA and RB only. Go to RA, debug IP OSPF adjacency. Debugging is on to the same in RB, debug IP OSPF adjacency. Both the routers are enabled debugging of IP-OSPF adjacency forming. Any DR election VR dash we can monitor from these routers. Now disable the G0 bar 0 interface on RC. So this is now DR, right? So if we disable this one, this will be inactive and the BDR will become DR. How it is happening? Just go here RC. Just go to options, preference, and always show port label. You can see this is G0 bar 0 here, G0 bar 0 here, G0 bar 0. So this one I'm going to disable. So go to configuration mode, interface G00, shut down the interface. Okay, I shut down that one. You can see this sniper 31. Okay, just wait about 30 seconds. Okay, so that dead time is to expire. So that means there's no communication from this router to the other routers. Okay, that's what dead timer. Okay, now we'll go to each router and check. Okay, see, elect DR 31.22, BDR 31.11. Okay, this will become now DR because once this RC is down, RV, it was BDR earlier, backup designated router, now it will become DR, and the one which was DR other will become now BDR. That's what it's showing. DR is 31.22, BDR is 31.11. Okay, so the same in RB router. See, DR is 31.22. Now debugging means by using that command we can see how the election going on. BDR is 31.11, RA, RB is now DR. Okay, now restore the interface on RC2 by giving no shut. Okay, so same RC interface 0 I'll give no shut. See what happens. Go fast forward. Wait for the new election. Again, check here and go for some debugging. Enable debug IP OSPF adjacency is on. Okay, also on. Enable debug IP OSPF adjacency. Okay, now did that DR and BDR all change? Show IP OSPF neighbor 31.11 is still BDR. Okay, DR other is 13.33. That means this is the DR now. RB is still the DR, not changed. Now go to here, show IP OSPF neighbor. You can see 31.22 is still the DR. Okay, we didn't clear that IPOC process and the election is still no that is not done. Still, this is the even though we enable the D0 back, but still that election is not happened and that clear IPOC is not done. So still, this is the DR. This one is PDR. Okay, they does not return RB and DR as see if the show IP or SPF neighbor does not return RB as DR and RA as BDR, turn on the debug, turn off debugging. No, but for us, okay, this is the DR itself, this is BDR. It's now changed. Okay, now disable interface on 0.0 on RB. So what is the status now? This is DR, this is BDR. That means if this interface, this router is down, means this will become designated router because this is the BDR now, right? See here, as per the output now, full BDR 31.11. This is the BDR. Now this has to become DR once the DR is down. So what I will do, I'll disable this to some also do. Go to config interface G0 then shut down. Now see what happened. Which one will become DR? Go here and check. Show IP OSPF neighbor. Now see 31 to 10 is the DR. Now DR has become RA become DR. Okay, because this was the DR earlier. This was BDR. Now this was down me. This will become BDR become DR. Okay. Now I will what I will do now according to the debug output RA become DR. Yes, done. BDR will be this will become BDR. Go because there is no other router. This will become backup. Okay. Go here and check. Show IP OSPF neighbor 31.33 is full BDR. This is not there, this will become DR, this will become backup router. Okay. Now enable this interface back. So restore this. So I'll go here and in the G0.0 I'll make no shut. After making no shut, wait for the election happening, okay? But still that role change or not, that's what I'm checking, okay? So we'll go and check again. Still BDR is 31.33, okay? 31.22. In ERC is now BDR, same BDR. RB DR other. That means RA is the DR. How do we check this? Show IP OSPF interface. See, this is still DR. Okay. Status of RC now. RC is DR, BDR, but still, how do we check that? Show IP OSPF interface. In RC, you can say this is BDR, backup designated router. Now turn off debugging and all RA, RB to disable debug. Okay, so how do we turn off? Let's go for this one. Undebug IP OSPF. Let's see. Sorry, ADJ. Done. Same command in RA. Debug IP OSPF ADJ. Done. Now we are going to configure the priority. See, till now there is no priority assigned for routers. So we just assign the loopback IP. They are which one? Choosing the DR based on the loopback IP and the interface IP. Okay, now we are going to configure the priority on each router. So go to see step 1 part 2, RA will be assigned priority 200, RB will be 100, RC will be 1. So this one has the highest priority. So the router which has highest OSP priority will become the designated router. As per this coding, we will have RA as DR, RB as DR other, sorry BDR, RC will be lowest priority default 1, so it will be DR other. Okay, so we'll go to RA first, configure mm, interface G0.0. IP OSPF priority. This one will be 200. Maximum is 255. Okay. See when I go here and question mark, maximum value 0 to 255. If it is 0 mean minimum, they will not participate. They cannot participate in election process. Okay. Start from 1 to 255. 255 is the maximum. Now this one for RP it is 100. No. So go to config interface G0.0 IP OSPF priority 100. Then this one RC the priority is 1. See RC priority for priority 1. So go to config interface D0.0 IP OSPF priority 1. Now I want to force the election by resetting the OSPF process. Okay, I have to force the election. How do we reset the OSPF process? Clear IP OSPF process on all routers. Okay, you go to each router. I'll type this clear IP OSPF process. Yes or no? Yes. small address. Now this is in RC. Go for RB also same thing. Ent clear IP OSPF process done. Same command in RA. Clear the IP as process. Okay. Ent clear IP OSPF process is done. Now we want to check whether the DR BDR election happened successfully and what is the now current status of each router. Okay, go for RA or maybe go for RC and check. Show IP OSPF neighbor. Okay, now DR is 31.11. How? Because the priority is highest with 200. BDR is 100 because this is the one. RA is now DR because the priority is 200. Okay, BDR is 20. This one RB because its priority is 100. Okay, that one with lowest priority will become DR. Okay, second one will become BDR. First one highest priority will be DR. Now go to RA. Check the same command. Show IP OSPF enable and see 22 is RB BDR. 33 is BDR other than RC. That means this is which one? DR. Do the same in RB. Show IP OSPF neighbor. 33 is DR other. So RC is the one with lowest priority 1. So DR other. 11 with highest priority 200 is DR designate router. Okay, so this will be DR other. Now how do we check again? One more command is there. Show IP OSPF interface. When you try this, you can see in RA we can see this is DR. Okay, this is how this DR and VDR selection happening and how to change on this status. How do we check that DR or VDR? What's the state?